Hello everyone, my name is Yuchen Cai and I'm glad to introduce you our work at Advancing Semi-Supervised Task-Oriented Dialog System by JSA Learning of Discrete Latent Variable Models. This work is mentored by Zhijian O and supported by SPIMI Lab, Tsinghua, and China Mobile Research Institute. I will introduce you our work in 6 parts. First, let me introduce you the information flow of TOD system, which involves dialog stage tracking, database query, policy, and response generation. Recent research records TOD as a sequence generation problem which achieves great success on datasets like multi-routes. Despite the success, increasing interest in semi-supervised learning have been aroused, and latent variable model is a frequently used method in modeling semi-supervision problems. Our latent variable model in TOD system is shown on the right, which involves a generative model and an inference model. A prevalent method of solving the optimization problem of latent variable model is variational learning, which minimizes the KL divergence between the posterior distribution and inference model. It solves the optimization problem by maximizing evidence lower bound, elbow. However, to learn discrete latent variable models, the gradient estimator for the inference model parameter is known to have high variance. Meanwhile, variational learning indirectly optimizes the lower bound, elbow, which leaves an uncontrolled gap between the target and the bound. Recently, an alternative algorithm called joint stochastic approximation (JSA) has emerged for learning discrete latent variable models with impressive performances. JSA directly optimizes the marginal log likelihood and avoids gradient propagation through discrete latent variables completely. In our study, extensive experiments and analysis shows the advantage of JSA method over variational methods. Therefore, we propose our system JSA-TOD. Related work. There are increasing interest in developing semi-supervised TOD system, which aims to leverage both labeled and unlabeled data. Roughly speaking, there are two broad classes of semi-supervised learning methods, the pre-training method and the latent variable model methods. Pre-training methods have been shown to improve the performance of language models, while latent variable models used extra posterior knowledge to help infer labels and achieve great performance. We show that pre-training can be successfully combined with our JSA method. Mentioning JSA method, we want to introduce some background. Traditionally, variational methods minimize the exclusive KL divergence between the true posterior and the inference model, while recently, researchers have found good statistical properties of inclusive KL divergence and developed JSA method. JSA methods have been already used in computer vision tasks and semantic parsing. However, our work is the first to use JSA in dialog tasks, which is a conditional sequential version. Before introducing our work, let me introduce you some preliminaries of JSA method. First, the objective function is on the right, which is to optimize the marginal log likelihood of the samples, as well as the inclusive KL divergence between the posterior distribution and the approximated distribution. We use stochastic approximation framework to solve the optimization problem, which is somewhat like two models versions of SGD. The method iterates Monte Carlo sampling and parameter updating. We use Metropolis independent sampler during Monte Carlo sampling. In summary, the underlying mechanism of JSA is to propose, accept, or reject, and optimize. It established JSA as a simple and solid approach to learn discrete latent variable models. Now we can introduce the structure of JSA-TOD system. As you can see, the system contains a generative model and an inference model, both fine-tuned from a pre-trained language model. The latent variable in our model is the concatenation of the pre-state and system act, which is annotated in the labeled dialogs and become latent variable in unlabeled ones. Another detail in our implementation is that we use Markovian generative architecture, which uses the brief states of the last term as a simplified version of dialog history, a commonly used way to improve efficiency in training speed and memory. When given a mixture of labeled and unlabeled data, we can conduct semi-supervision with our JSA-TOD system. First, we randomly join a batch of dialogs. If the batch is not labeled, we first use recursive turn-level MIS sampler to sample the latent variable. The sampling method is comprehensively introduced in the paper and is skipped here due to time limitation. After the sampling is done, the unlabeled batches are treated the same as labeled batches, and we can calculate the cross-entropy loss of both inference model and generative model and update to parameters. Use the method introduced we conduct our semi-supervision on multi-woods 2.1. We used end-to-end evaluation and followed the evaluation script in this paper. We conduct our experiments on full proportion, each 3 times with different random seed, and the mean and variance is reported for informed, success, blue, and combined score. As you can see in the table, our JSA method outperforms its variational counterparts by the large margin. We also conduct 4 ablation studies. The first is to show that our recursive turn-level MIS sampler significantly improves performance of the system. The second is to compare the performance of model among supervised only, variational method, and JSA method. We can see from the result that JSA method continuously improves the performance of inference model while variational method don't. This result gives us an insight of why JSA method has an advantage over variational method. The third is to compare gradient norms from the inference model during training. It is clearly shown in the picture that the training procedure in variational learning is much noisier. Similar results have been given in this paper, which is also an evidence that JSA method has advantage over variational method. Finally, we combine JSA method with retraining. We pre-train our inference model and generative model unlabeled data, as well as for other task-oriented dialog system datasets. We can see that combining JSA method with pre-training, our JSA-TOD model can achieve competitive performance with only 3% of labeled data. We can summarize our work in the following 3 points. First, this paper builds semi-supervised TOD system by leveraging recently emerged JSA method, which surpasses variational learning methods. Second, extensive experiments showed the superiority of JSA-TOD over its variational learning counterparts, not only in benchmark metrics for semi-supervised TOD systems, but also from the latent state prediction and performances and training stability. Finally, combining JSA method with pre-training, few-shot learning in TOD can be improved significantly. Thanks.